Somewhere on a dark beach tonight, a creature older than the dinosaurs is crawling out of the surf. It has 10 eyes, it has a tail like a spike, and its blood is blue. Not blue like a bruise, blue like the sky. Why would evolution paint an animal's blood a color humans associate with the ocean? This is the horseshoe crab. It has barely changed in 445 million years. Trilobites came and went, dinosaurs came and went. The horseshoe crab just kept crawling. And here's the twist that surprises almost everyone who learns it. Despite the name, it isn't really a crab at all. Genetically, it's closer to spiders and scorpions. A crab-shaped arachnid, hiding in plain sight for nearly 500 million years. But the blue blood is the real story. Human blood is red because it carries iron. Horseshoe crab blood is blue because it carries copper instead, in a protein called hemocyanin. That alone would make it strange. What makes it priceless is what happens when that blood meets bacteria. In the 1950s, a pathologist named Frederik noticed something odd. When horseshoe crab blood touched even a trace of certain bacteria, it didn't just react, it clotted almost instantly, sealing off the threat like a wound closing itself. Bang suspected this could be useful. A few years later, working with him, researcher Levin isolated the exact cells responsible, amoebocytes. Together they helped turn this discovery into one of the most important tools in modern medicine. Here's why it matters. Every vaccine, every IV fluid, every implant and surgical instrument has to be checked for bacterial contamination before it reaches a patient. Even a tiny amount of certain bacterial toxins can cause fever, shock, or death. So scientists extract the clotting agent from horseshoe crab blood, called limulus amoebocyte lysate, or LAL. Drop a sample of medicine into it. If dangerous contamination is present, it clots. If it stays clear, the medicine is safe. That one test, born from a crab that isn't a crab, protects nearly every injectable drug on the planet. Millions of lives. All checked by blue blood from a beach. Is that enough to make this animal important? Consider what it costs. Roughly 500,000 horseshoe crabs are collected every year, bled in a lab, then returned to the ocean. Most survive. Some don't. And their eggs are a crucial food source for migratory shorebirds. So a shrinking population doesn't just affect medicine, it ripples through entire coastlines. That pressure is why scientists have been racing to replace the test altogether. In Singapore, researcher Jake Ling Ding helped develop a synthetic alternative called recombinant factor C, built in a lab with no animal blood required. It works the same way the natural clotting cascade does, without touching a single crab. So the next time you get a vaccine, think about what happened before the needle ever reached you. Somewhere a blue-blooded creature that isn't a crab, that predates the dinosaurs, that has survived 5 mass extinctions, quietly made sure that shot was safe. Not bad for an animal nobody thought to worry about.